Can everyone see the screen? Kalyani, Nageshwar,
Yes, sir.
Akira. Yeah, okay.
Yes, sir.
Done. Okay, so up till yesterday, we came across this structure of the ion beam lithography, actually, how the ion beam lithography is made using the metal sources and sometimes the gas sources. Of gas sources are generally hydrogen and helium, and metal sources are AU and SI, or these kind of metal sources are used for the uh, what I can say that ion beam lithography, actually. So this is forming the ion sources, is that the way of forming the ion source, and then it is revolving with our aperture, resolving aperture, and then it is being normalized using a lens, and it is falling over the wafer, actually. Okay, now we understood the ion sources, like how the ion sources are created. Electron bombardment is done the ion source to create the beam, which is a noble gas. It generates a noble gas, so low energy, that is Ar plus and He plus. Then gas discharge happen, field ionization sources are there, liquid metal ion sources are there. These are the some of the couple of sources of the ion sources. Okay, after this we have to go to the ion metal source. What is the metal actually doing? We have understood the sources. Now detail we will understand the metal source. Now ion metal source emitter, the small end radius. Okay, the emitter, actually this is the emitter part, this small thing is the emitter part. Okay, so the emitter small end radius coated with metal having high surface tension and low vapor pressure and its melting point. Okay, at its melting point. So these are couple some of the couple of definitions, or the key concepts of the emitter, actually, for the iron metal sources. So in this one, the emitter actually small and radius coated with metal having a high end surface tension and a low vapor pressure at its melting point. Actually, if I tell you, these are very much detailed concept related to the ion beam lithography. Majority of the times, no one is going to ask you these concepts. Okay, so you can avoid these things also, but for here we have to study. Then comes the emitter is heated to the melting point of the metal, while the high positive voltage is placed on its relative to the extraction electrode. Okay, the emitter is heated, the emitter point, actually, from where it will be out generating that source, that part is heated to the melting point of that metal. Then the metal is being melted in a liquid form, where while a high positive voltage is placed on its relative to the extraction electrode. Okay, so there is a two part. There is an extraction electrode, you can see liquid metal is there, and this pencil type thing, this is the that emitter. Okay, so this emitter, this part is heated at the melting point of the metal, and then the metal gets formed into liquid, and then a positive voltage is placed in that one, and then it is released, that extraction electrode is released, actually. Okay, then from here the ion is released. If you see, this has been zoomed in, and it is in shown here. Okay, the liquid metal is drawn into in a conical shape by the balance between the electrostatic and surface tension forces. If you see, the liquid metal is drawn into a conical shape. This is a conical shape, actually. If you see cone shape, like you have ate ice cream, that softy, that cone shaped ice cream, that kind of cone, conical shape, by the balance between the electrostatic or and the surface tension forces. Okay, so like mehendi, that mehendi thing is there now, that from that pouch it is been pressed out and the conical tube is there, from that the mehendi comes out. That kind of structure is this. On that side only, what a kind of heater is there, which is heating that metal, which is becoming at the metal is melting to its melting point, become liquid form. Okay, the liquid metal is drawn into the conical shaped by the balance between the electrostatic and surface tension forces. The apex of the liquid cone is drawn at to the end radius, so that so small radius to so small that the high electric field causes ion to begin to form through field evaporation. Okay, the apex of the liquid, that a liquid in that cone is drawn to the end radius at so small that radius is, that the high electrostatic field cause ion to begin form through field evaporation. That high electric field causes ions, okay, which begins um, the evaporation status there. Okay, that is the how the liquid is formed and extracted from that conical shaped extraction electrode. Okay, so the cone is believed to have a radius of 5 nanometer. So you can imagine how thin that is. That cone is. That 5 nanometer is very very thin actually. Okay, so the most common metal is gallium, because most common metal used here is gallium only. Okay, and AuSi and AuSi-Be alloys have also been used in lithography because these sources can supply lighter mass ions. The AU or AuSi and AuSi-Be, al- the mix of the alloy of this kind of mixture alloy are used also in the lithography because they generate lighter mass ions. Most use is gallium. Okay, and the apex, the cone apex, which it is responsible for generating the whole ions actually, ion beam, that the diameter, the radius of that one is 5 nanometer actually. Okay, so 5 nanometer is very very thin actually and small also. Okay, this is how the iron metal source is generated. Actually, if you see the emitter point view, it has small end radius. Okay, it is the coated with metal having high surface tension. The tip is coated with metal which has a high surface tension and low pressure at its melting point, so that the way the heater passes the liquid metal, the metal coated over that apex cone does not get mixed with that one, or does not get melted. Okay, the emitter is heated to the melting point of that metal. The emitter is heated, and while the high positive voltage is also placed on the extraction electrode. Okay, now the liquid metal is drawn into the conical shape. Okay, the liquid metal is drawn now into the conical shape between the and then it is passed. Okay, because the surface tension in between the surface electrostatic surface tension and that electrostatic and surface tension forces, between that one it is been passed. Okay, now the liquid, the apex of the liquid cone is drawn to the end of the radius, and it is so small that a high electric field caused by ion to begin form a evaporation. Due to that reason, a high electric field cause evaporation actually. The cone apex is believed to have radius of 5 nanometer. It's very small. Okay, the most common sources here is gallium, and AuSi or AuSi-Be alloy is also used because they produce lighter mass ion. This is the advantages and the making of the iron metal ion source. Okay, this is the image of that one, the conical shape apex, the heater, the extraction the extraction electrode which producing the high voltage charges, and this is the the zoomed in image of that one. Okay, that cone, how it is being forming, that ions is coming. Okay, now comes to the gas source. How the gas source is the ionization region from this plasma formed. Actually, when the gas is heated and then up, it is placed between a high voltage. Okay, it creates a plasma. I have already told earlier how plasma is created. When plasma is created, when I can say when it is being placed inside when chamber which have a high voltage, when the gas is passed from that part, it creates a plasma actually. Okay, potential placed at extraction region removes the ion from chamber. Okay, now if you see this chamber, gas is coming from the top, input power is given here, due to which it is creating a plasma. Okay, this is the ionization region, this is the plasma. Here it is generating ions actually, a beam of light it will generate. Okay, and here a thin tip will be there, like that of the iron one. A thin tip will be there that will generate that ion beam at a very precise point. This is how the gas ion source works. This is how the metal ion source works. Okay. Is it clear to you guys that how these two gas ion source and metal ion source system is working? Hello? 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 Can anyone can you guys tell me that is it okay for you to understand? Hello?
Yes, sir. Yes, sir.
Okay. Here my actually sounds are not coming. Is it my headphones sound?
Yes, sir. Your voice is not audible, Subhashish.
Hello, is it now audible?
Yeah,
Yes,
now
you are
it's
now audible.
fine.
Okay, okay. Okay. Where did you guys left off? Can you tell me? Are you unable to hear? From which point? Hello.
After you're asking that you're
Gas ion
this is
process,
clear.
sir. After gas ion process, we didn't hear, sir.
Like what is the explanation of the gas ion process also didn't hear?
That was clear, sir.
Okay, from lithography unable to hear, right?
Yes, sir.
Yes.
Okay, okay. Like lithography, you guys already know. Okay. The lithography, what happened just now? 1 second. Lithography is employed to define a pattern inside a target. Okay. Pattern can be defined by physically sputtering the target. Like lithography, you all know it is the technique to put the pattern over a target. If the target is our wafer. Okay. The pattern can be defined by ion implantation, chemical reaction, physical sputtering. Okay. So generally ion implantation only we use over the lithography technique. Okay. Or UV lights. So or the or the X-ray or the electron beam. Okay, so currently we are using ion implantation only in the latest technology across the industries. Okay, so lithography, you guys all know. I do not need to teach this one again. Okay, so let me go to the FIB milling and gas assisted processing. So what is FIB milling? You have heard this term FIB milling here. Okay, when an ion hits the target, okay, surface surface elastic and inelastic scattering process will take place. Okay, inelastic process are responsible for the generation of photons and secondary electrons. Okay, like when an ion hits the target, surface elastic and inelastic scattering process will take effect. Like when an ion hit the particular target, like our wafer in our case, the surface elastic and inelastic scattering process will take effect. Okay, take place. Inelastic process are responsible for the generation of photons and secondary electrons. elastic process scattering will transfer kinetic energy from the ion to the target atom. Okay. If you ask me that what is inelastic and elastic process, inelastic process are responsible for generation of photon and secondary electrons, and elastic process scattering will transfer kinetic energy from the ion to the target atoms. Okay, the energy transfer will cause the displacement to the target atom and trigger, sorry, and what second, what is this triggering, what is that, and trigger a recoil cascade. Okay, it should be a recoil cascade. Okay, wherever kinetic energy is transferred from one atom to the another by elastic scattering process. Okay, it is like the transfer, the energy transfer will cause the displacement of the target. When a transfer like from excuse me, from the kinetic energy of the ion, when will get transferred to the target atom, that is called a drift. Actually, you will be reading this term in the electromigration technique also. This kind of thing happen when the ion, the momentum of the ion gets transferred, the what is called the kinetic energy to get transferred to the atom or the nearby atom, it creates a sudden drift. Actually, that drift is actually that the drift is actually called here the energy transfer, and in that case it is called the electromigration. I will come there a little bit later. Okay, the energy transfer will cause the displacement of the target atom and trigger a recoil cascade wherever kinetic energy is transferred from one atom to the another by elastic scattering process. Okay, number of target atoms a single ion is able to remove is largely dependent on the target material, the ion species, its energy, and the angle of incidence of ion beam. Like number of target atoms a single ion, the number of target atoms a single ion is able to remove is largely dependent on the target. So the transfer of this kinetic energy from ion to the atom, it's dependent on the target material. Okay, the ion species, what kind of ion, from what it is generating the ion, for what metal or gas it is generating ion, its energy and the angle of incidence of the atom, also of the ion beams. Okay, so these are the major factor of the FIB milling and the gas assisted processing. So this happens, suppose when the ions, let me tell you, like when the ions, one second, over the paint, let me tell you. When this from when this tip it is coming, the ion when it is coming falling, the ion when it is falling, actually when the ions are falling from this tip actually. Okay, over this wafer. Okay, where this wafer it is falling, when suppose a targeted atom is suppose one step it is falling at this level. Okay, like this it is coming, and then a lens, suppose a lens is there, a lens is here actually. Okay, a convex lens is there which is targeting this which is compromising this light and making it fall over the this part. Okay, what happens now, if you see here, the angle of incidence, so what is the ion, so what quality of ion is generated from what kind of source. Okay, target material, that what kind of material, what wafer, how the doping is there, what are the quality of the wafer, that matters, the ion beam quality matters, and the angle of incidence matters. If you read the light, you will know what is the angle of incidence. Okay, so that angle of incidence actually very, these three factor matters. Sorry, these three factor matters actually, how these all things will be taken care. Okay, so number of target atoms, so like how many atoms over that wafer will be targeted by this ion beam is completely depend upon the material, ion species, the target material, ion species, its energy, and the angle of incidence of the ion beam. Okay, now you got. So now if it has to touch 100 atoms, then the quality of, suppose example, 100 atoms, then the quality of the ion beam should be much more efficient. The source of the ion beam, the quality of the target material, the angle of incidence, all should be very accurate in compared to the 10 atoms consideration. If suppose a 10 atom consideration, this value might be fitted, but if you're going for 100 atoms you want to target, then the quality need to be improved. So that kind of concept is actually here. Okay, so is it now clear how FIB milling and gas assisted processing happens? Hello, hello. I got how about the FIB
Yes.
milling happens?
Yes, sir, we are there.
No, if you don't get, tell me. I will again help you out.
No,
Because
sir,
this
we did not get.
then why telling you got? Then why telling you are got? Tell the truth, man. Nothing will happen. I'm here to teach you again only. Okay. See, these things are very fundamental physics, very much fundamental physics. Okay. These things will only get clear to you if you see, if I teach you, if you actually read these things only, you will be able to learn these things. Okay, learning is not a point in analog layout or in any field of the engineering. Okay, you need to be get the concepts in detail. The concepts, this see what is angle of incidence, what is atom scattering, these things, or the half-life decay, these things are class 11th and 12th physics. These things are the university first year physics. These things, these fundamentals should be very much clear to you. These basics, this should be clear when you are going to engineering background. Okay, so it will be clear to you only and only like I have taught you. Go and see that video once again, read this document. I will be sending this document today. I will complete this ion beam lithography today, and I will be sending this document to you. Read it. See, watch the video. If you don't get, come back to me again. I will repeat it. Okay, because see, understanding the flow of fabrication. Okay, okay. Can you guys confirm me up till what part of fabrication you guys have understand? Can you tell me? Hello, hello. Up till what part of fabrication you have understand? Hello, hello.
Yes, sir, we are there.
Like, can you tell me that what part of fabrication things you have understand up till date?
Like lithography, photolithography.
Like
And
etching, yeah,
itching
tell.
we got, itching I got, sir.
Then iron beam lithography.
Yeah, okay, fine, sir.
No, iron beam lithography you got.
Yes, sir.
So, like,
So, like if
yeah,
we go deeper and deeper, I am unable to understand, sir. I don't know about others.
no, that's fine.
Yeah.
That's fine. That's not a big thing. See, it see if you see these topics, this term you might have heard when you are in class 12 or university physics. When you're in first year, you have heard this angle of incidence, atoms, scattering of ion, then making this kind of plasma devices. You have heard these things on that time. So after this one, like fact, this means fact of the Indian universities are they they take admission to of the students in different fields, but they actually tells the guys to learn only coding. So guys are only oriented to the coding. They don't know anything basics of the engineering. So that's very fact of the industry. So no one can do that one, though. That's the education system of India. Actually, everyone wants to learn coding, and university tells them to learn coding. Out of the university gate, you will find lots of coaching center. Some coaching center will be there, coaching center, egg shop will be there, and some pan masala shop will be three kind of shop you will find the front of engineering college. And some side you will find project house also. They makes project for the guys. Is I am right, Nageshwar? Hello,
Yes,
Nageshwar.
yes, sir.
Is
Yes,
I am
yes.
right? You will find three, four actually there. Like pan shop, pan cigarette, then that beetle shop it's called, then one project house which make projects for the final year projects for the guys, one gym, one egg shop, and couple of training institutes easily available. So these things need to actually be, you have to read these ppts. I will be sending today only after the class I will send it. Okay, after this
Sir,
ppt read, yeah, tell.
yeah, if possible, can you send the related videos, like the complete process of a complete steps involved in making a chip?
See, complete how iron beam is made, you will not getting. But what is the flow of this fabrication process? That video you will be getting. How this lithography machine is created, how this iron beam is generated. These things you will not be getting actually, because these are very rare actually. No one actually provide this one. The video I haven't seen in my life till date.
Okay.
Diagram I have seen how iron beams is generated, how iron beams is made, how plasma is made, but I never saw any animated video also for this one. So the whole fabrication process that you will get, either from Intel or from TSMC Fab Lab. Someone has made video and uploaded to YouTube. We will get that one. I will find and I will share it to you guys. Okay.
Okay, sir.
And what about others? Hello. What about others? Can you tell me? Kalyani, Hiranmai, Akila, Nanda. Can you tell me what about others? Hello.
Hello.
Yeah, hello, Nanda. Tell.
Sir, I just need to go through them, so that's it. Like I understand some of them, but I just need to
Okay.
go through.
Okay. Good to hear. What about Akila and Kalyani? Hiranmai is
Some
typing.
some topics I didn't understand, sir. I will go through recordings.
Which topic you can tell?
So lithography.
Lithography, iron beam lithography, right?
Yes, sir.
Okay. Just go through the topics. Read that. I will sending that PPT just now. Read it. If you don't get, come back to me. I will help you again. Okay.
Okay, sir.
In the last, understood, sir. I need to go to the slides again. Okay, Hiranmai. So last time the PPT what I shared with you, is it up till what I have shared? I don't remember. Let me see that one. I think part one. I think up till, I don't remember up till where I have shared with you guys. Let me check. I think up till etching I have shared. So fine. Today I will be sharing the next part of the iron beam. Okay, that will be great to do. Okay, now we can consider, we can go to this process part. So if you see this FIB process, which is like, this is the diagram that what we just discussed just now. This is the a focused ion beam. Chlorine molecules are there. Desorption silicon tetrachloride, SiCl4. Okay, these are the chemicals. You do not need to take care why chemicals are used, because you are not a chemical engineer. It is part of that one. So so on the wafer, this kind of ion beam when falls, it creates, see, this is the Si. It is doped on, this is the wafer below box one. because of an SI. So silicon dioxide is there, SI coating is there. In that one, when the lithography is falling, it is displacing the atoms from the blue. It is becoming that blue atoms are getting separated, and ion beam, that gas atoms are coming and touching this one, which is these chlorine molecules are also there, solvent there, and it is discharging silicon tetrachloride. See, chlorine molecules with silicon, with the presence of the focused ion beam, it is generating silicon tetrachloride SiCl4. Okay, this is how this focused ion beam milling process actually happens, and the gas assisted processing. This is how the process actually works at this level. Okay, so if you get to know this diagram, then much of the concepts will get clear here. So if you see here, inelastic process, like uh, inelasticity, you might have read in that 11th physics, I think. Not young modulus of elasticity. I think that's elasticity process, and inelasticity, I think it's in the surface tension, viscosity. I think in that parts it should, in kinematics, it should be there. Elasticity and inelasticity. Okay. Inelastic processes are responsible for the generation of photons and secondary electrons. Just need to remember this. Okay. After you come here, you will see this diagram that focused ion beam is falling over this wafer in which silicon is coated Si. Then chlorine molecules are touching this guy actually here, with the presence of these chlorine molecules. In the Si, the focused FIB, the focused ion beam is falling. After the reaction of the atoms is displacing that, this Si atoms are getting displaced when the FIB is falling, and it is generating silicon tetrachloride SiCl4. This is the whole process how this ion beam things is happening. Okay. Now next comes to this same thing. Again, the same thing is happening here. Okay, the same thing, ion milling, how same thing happening on the substrate. It is actually falling, that ion beam is falling, this pattern film is there, that whatever that mask, actually that's called the pattern film here. They have mentioned the name. And it is when the ion is falling on the ion, the atoms are getting scattered. Okay, it's moving in this side, that side. And this is the gas nozzle on the deposited film. It is putting that gas molecule, if you see here, and this chlorine molecule, these are actually chlorine gas, not the chlorine liquid. Chlorine is a gas molecule falling here. Okay, and then it is generating this, then this fabrication is happening, the pattern is getting etched there, in which the output liquid is for the chemical is for forming is silicon tetrachloride SiCl4. If someone asks you what is the extract output of the, what is the name of that chemical which is being generated after the FIB process is done in the presence of chlorine molecules. If someone asks you like this also, what is the extract chemical, that resultant chemical after the FIB is done, you have to just say silicon tetrachloride, which is SiCl4. Okay, how it is done, you have to tell. You have to draw this substrate. You have to tell this Si is there, chlorine gas is there, FIB is falling, and it is getting reacted, and it is displacing the atoms, which is scattering due to the due to the focused ion beam. Then it is resultant liquid is silicon tetrachloride, which is SiCl4. Okay, this is how it is being created actually. This is how it is being actually created. Okay, so this is the way actually focused ion beam is generated. The same diagram is again put here. Okay, this is the scale. If you see, this is the second again the second diagram, same diagram, which a much more proper view it has been given here. Okay, now if you see here, you will be seeing these two kinds of, okay, that patterns are, like you can see this pattern here, that this is the mask pattern. This is the, so this is the design you have done. This is the mask pattern generated on somewhere. Then this has been cut out and for use for there, and then the light is falling from this part. now if you come a second example of the 500 nanometer, that kind of pattern. So this kind of pattern results this kind of design. So in the place of ruthenium, actually when you use this kind of pattern is created. When aluminium doped zinc oxide azo is done, then this kind of much more detail is created. Okay, so which is like 4 nanometer, this is 10 nanometer. Compared to this one, it is much more precise. So this is just an example, nothing else to explain in this one. Is just an example. When we go to more small sized, the lithography things become more efficient and resolution becomes more higher, optical resolution, due to which the detailing is much more higher in that case. Okay. Now comes the advantages and the disadvantages. Advantages are higher exposure sensitivity, two or more orders of magnitude higher than that of electron beam lithography. Ion beam lithography has two or more orders of magnitude, which is higher than the electron beam lithography. If you see the comparison, you have to just normal, you can say higher exposure sensitivity. It is 2 times higher than the electron beam lithography, ion beam lithography is. Okay. Negligible ion scattering. Ion scattering is very negligible in ion beam lithography, whereas electron beam lithography has a scattering on that one. Okay, it gets scattered. That's the reason this kind of blurred image is created, and this one so much precise and proper image is created. This is the electron beam, this is the ion beam. Okay, so the scattering is less, so the resolution is much more precise. Low back scattering from the substrate, so substrate also the scattering is very less. Can be used as a physical sputtering etch and chemical assisted etch. This can be used for this also. So this doesn't required for you guys. You can just let me do. You can just black out it. Okay, this point is not required. So can also be used as direct preposition on chemical assisted deposition or doping. Okay. This can also be direct, the ion beam can directly be deposited, or chemically assisted deposition can also be done in this one. Okay. If you see, the ion beam can directly deposit on the wafer, or it can be assisted with a chemical also. The diagram what we see, this is the chemical assisted. Okay, this is the chemical assisted. Sometime it is gas assisted, sometime it is direct, depends upon the technology process. Okay, these are couple of the advantages of the ion beam lithography, whereas the disadvantages are lower throughput and extensive substrate damage. Due to its high power, ion beam lithography is so powerful, it it damages the substrate many times. So that's the reason a polarizer is used to like decrease its power, which polarize the light, and which actually soften the light to make the fabrication also happen, and it does not damage the wafer. So if anyone asks you what are the advantages, pros and cons of the ion beam lithography, you can tell it has high exposure sensitivity, negligible ion scattering, then it can be direct deposition or chemical assisted deposition can be done. And the disadvantage is lower throughput and extensive substrate damage is extensive, high, and lower throughput. So how this extensive substrate damage can be reduced? By using a polarized lens. The effectiveness of the light, which is the power, which actually decrease that one. It changes, it suppress that power. Actually, that's the reason how it is being done. Okay, now if you have seen, after this ion beam lithography is done, I've already told in the time of lithography and annealing technique. The annealing technique already I have told earlier. If you go in the top sheet, you will able to see annealing. It is the process that produce conditions by heating to the above critical temperature, maintaining a suitable temperature, and then cooling. So this annealing thing already I have explained. Again, I am telling this annealing thing. After this ion beam lithography or the lithography is done, a annealing process has to done for each and every step. Either you create N-well, either you create polygate, either you create metals, or any layer you create. You have to do this process again and again. This process repeats for each and every layers. Okay. So annealing, it is a process that produce conditions by heating to above critical temperature, maintaining a suitable temperature and then cooling. So this is the definition of the annealing. Just you could tell it has been explained much more detail in the top slides, other slides. Okay, annealing is used to induce ductility, soften material, relieve internal stress, refine the structure by making it homogeneous, and improve cold working properties. Okay, these are couple of the in the last earlier slides the what I can say the advantages of the pros of the annealing was not there. So here you can see the pros of the annealing. The annealing is used to induce ductility, soften the material, relieve internal stress, refine the structure by making it homogeneous, and improve cold working properties. These are a couple of the things annealing is used actually. Okay, there's some of the things the annealing for which the annealing is being used completely. After when you comes, the annealing is done. The next other steps are taken care for the next other layers. This is how a complete fabrication step happens. So in a fabrication step, if you comprise, almost it has been said that it passed from a 800 steps to make a one chip. To make one chip, it takes 800 and above steps to create one. So minimum is 800 till now. So 800 steps processes it passed to make a particular chip. Just imagine how complicated and how soft, how it is a soft engineering, means how complicated engineering this is. Okay. The conclusion, last but not least, ion beam lithography is a versatile technique with several variation of the process. Ion beam lithography is found to be useful for transferring high fidelity patterns on three-dimensional surface. Because currently a 3D ICs we are using, which are FinFETs actually, or the GIFETs, in which ion beam lithography is much more easier to transfer to high fidelity patterns, so 3D surfaces. Okay, the process can anyway be advantageous to the application where larger surface area is needed. For the smaller one, it is not needed, but the larger surface area is needed. From that part, the ion beam lithography is very useful. So these are some of the benefits of the uh, ion beam lithography across the industry. So this is all about the ion beam lithography, how ion beam lithography happens, how ion beam lithography works. These are all about the ion beam lithography. Okay, how ion beam, we have discussed how ion beam lithography is done, how it is being generated, what are the sources, what are the pros, what are the cons, how ion beam lithography machine looks like, how the nozzle tip of that one looks like, what are the different sources, point gas and metal, then what are the structure, what are the chemicals are used in ion beam lithography, silicon tetrachloride HCl4 in presence of chlorine gases. Okay, then what are the resolution point of view if you go to that, and what are the material benefits. So I already told, due to it depends upon the different materials, like materials, target material, the ion species, the energy or the angle of incidence. This is the example. How did the angle of incidence resolution changes, material changes. So you can see aluminium has much more precise, ruthenium has a blurred image. So this kind of some points are very critical for ion beam lithography to happen. Then the advantages and disadvantages we came across. What are the advantages, the differences, how the disadvantages can be solved out. Then last but not least, annealing. What is annealing? After each step, the annealing is done. And then the conclusion, we ended up the ion beam lithography. So this is what about the ion beam lithography. Okay. So if there is any question, hopefully no questions will be there. You already told that all need to go through the PPT once again. I will be sharing with the PPT just now after the class. Have a look of this PPT, read it, come back to me again. I will explain you. But for your kind information, I tell you over the interview, no one is going to ask you in this much detail. They will just ask you what are the steps of fabrication. Just remember the steps of fabrication which was taught earlier of this CMOS fabrication topic. How the steps are done. These down. Just read all these things, but be particular with the steps. You should be knowing the steps very precisely. This should be you knowing, but if sometimes anyone asks you what is ion beam lithography, you should be able to tell, okay, this ion beam lithography is this one. These are the some couple of advantages. These are disadvantages. These are the sources of ion beam lithography. That much, and stop it. Okay, so don't go much deep. If you go much deep, interviewer will also tell you to ask you question in deeper, which may result lack of confidence, will make you lack of the confidence of your will lose, and you might answer wrong, and that will be your point of elimination. So better tell what have been asked you, don't tell what hasn't been asked you. Okay, this all about the ion beam lithography and all sorts of things. uh yeah, Hiranmai, in interview, they will not ask the equations. Of course, they will not ask the equation, but some of the couple of the equations I already told in the earlier stages. I have explained some equations in the etching process. The time of etching process, I have told one equation. I remember that equation they might ask, but this equation, this one, how the etching is done. This equation is very important equation. Okay, this equation. That's all. Other equation they will not ask actually. Frankly, still no one will ask because interview itself he don't know what he will only ask you. If any manager or director level guy have a text interview, they might sometime very rare, and that also rare they will ask. No one is going to. But remember this etching formula. That's you should be knowing. Okay. Okay. Is there any more question from your side, guys? You can ask me. Hello. I will be sharing the PPT just now to you. Guys, can you confirm me that are you all practicing some couple of circuits on the layout? Akila, Nageshwar, Hiranmai, Kalyani.
Sir, do you
Yeah,
have any
Akil.
PDF of this content, sir?
Which content? PDF means?
Steps, procedure for the, or we have to
Fabrication.
Google it.
I didn't got your point, Akila. Actually, can you explain a bit?
These topics PDF, do you have any, sir?
I have already shared with the PDF na, of the CMOS fabrication.
No, sir. She is asking the detailed explanation of the whole PPT. She is asking.
Of this big PPT. Of this PPT, like detailed explanation you want. So for this detailed explanation, like internet materials are only generally available. You can take care of that one. That's all I can suggest you. Other any particular, see, these materials are also made from the internet only by researching some other PPTs or research papers. Only that thing only these have been created. But much more details cannot be put because if I put, it will be difficult for you guys to understand. But very helpful I will be telling you, rather searching randomly over the internet, better try ChatGPT. If you are facing the issue, take this topic, what topic you are looking for, type in a ChatGPT. It will be much more be easier for to understand the explanations. Let me give you an example. Wait, let me give you an example. ChatGPT once. One second, let me open the ChatGPT. You guys suggest me one topic. For what topic I should search in the ChatGPT? Please tell. Akila, please tell one topic. What shall I search in the ChatGPT for you guys?
Lithography, sir.
Lithography. Okay, let me search. Ion beam lithography, right?
Yes, sir.
Okay. What happened to the internet? Okay. What is ion beam lithography in VLSI. Just type enter, it should be giving you the result immediately. It is much more easier to understand. Let it generate, it's generating actually. See, very precisely it will be generating you for you. You can search over the Google also, no worries. You can search here also, it will be much more precise for you to understand, because Google you have to screen a lot of the websites. It will take much time. You will study or you will waste time on that one. You can use Chat GPT for that one. What are the challenge? What is ion beam lithography? Now you can ask him how ion beam phy is made. Now you can ask him. You can ask questions on questions. It will tell you. Okay. Ion source, ion generation, how it is. See, gallium, I told you, GA. Then ionization process, ion acceleration is there. So focus ion beam, which we read today, FIB. Okay. So then substrate preparation. See, these are the steps. It is a PMMA. We discussed polymethyl methacrylate. Already we discussed last classes. So these are the steps it is generating for you. You have to just read these steps. It is much more in detail in compared to the PPT. In PPT, everything is very difficult to put. Okay. Now, is it okay, Akila? In detail?
Yes, sir.
You can use the Chat GPT. Of course, you can search over the Google also. That's not a big issue. See, fabrication itself is comprised of chemistry and physics and mathematics. Okay. So in physics, if you come across this whole fabrication, you have read chemistry, you have read physics, what I can say, uh, kinematics also, light also, viscosity also, and the nuclear physics also. This all physics consist and make a fabrication. So this all topic itself are huge. If you try studying each and every topic, it will be, I think, take took it will take for you, I think, a year for to understand the whole lithography process. Because if I tell you, many guys do PhD in the semiconductor fabrication actually. So fabrication itself has a different PhD, which comprised of a 5 years of topic. Okay, Akila. So
Okay,
it's
sir.
actually a complete. Many guys you will see they are semiconductor device modeling. They are inside that one, or they are inside the semiconductor fabrication things. They do PhD only on that one. One of our friend, I think, 2022, he completed the fabrication. He is in PhD in United States. I remember. I went to job much year ago from him, and in 2022 he completed his PhD. It took 7 years for him to complete the PhD on semiconductor fabrication. He is currently in the United States only, working on his postdoctoral. So it's a huge thing. So for an interview, this PPT is sufficient to answer. Apart from you want to gain knowledge, you can gain knowledge over the Google is sky is your limit. You can go to Google, you can go to books, you can go to what I can say. I will suggest some books also, which will be helpful for you. You can go to Chat GPT also. Many sources are there to understand. Okay. So, sir, can you say what topics we need to prepare? Own document is much more advisable, because it makes you uh, things clearer more. When you write notes on your own notepad, it makes you much more clear, because rather creating PPTs, take pen and paper, write the notes, write on your own handwriting. It will make you easier, because creating PPT don't makes you be, it's a copy paste. When you write anything, it will memorize you lot in your mind. Just draw the diagram, you will then read those things. Okay, so the whatever I have taught up till in the fabrication, go through that PPT once, then use that PPT for your reference, and you can read that PPT and then search over the chat GPT. Okay, I will be sharing couple of questions related to the fabrication things and the interview point of view. It will be easier for you. I think tomorrow morning I will share that or if I have just now, I need to update couple of questions in that one, and I will share it to you, okay, by tomorrow morning, that whole complete interview questions. So you just guys can have a look of that one and you can start preparation. Many things I have taught, many things are left to taught. Okay. Okay, everyone. If there is any no doubt, we can end the session here. Like Hiranmay is typing something, let her type, and then we can end the session. Stop the recording. Use ChatGPT, install the ChatGPT in your mobile phone also.